this video, I'm going to talk about how to replace the locomotion data inside the motion data asset that uses that is used by the motion flow system. So if we look at our motion data asset under motion flow, characters, mannequin, data assets, then we can find the DA underscore motion underscore combat jog. If you open this, you will find that the first 9 elements in this array are all locomotion, and then we start storing the docking animations here. In a future version, we are going to split the different kind of docks in their own motion data assets. But for the purposes of this video, I'm going to delete all these first 9 elements and then I will add a new locomotion set here. So first let's look at what the system looks like right now. So it does its normal combat jog animation where I can turn around in circles, I can go straight, I can turn around quickly, and it can do all that. So let's delete all the locomotion animation that generate that behavior. So I'm going to go and delete 9 elements. So now the first element should be the vault animation. So the next thing we need to do is go to our animation that we have imported. And here you can see that the character will pick up the gun and start locomotion style. I'm going to skip ahead and then going to scrub through the animation. You can see that it performs a locomotion maneuver in an injured style. So first we need to do is find the point where the character is ready to perform the action. And over here, I'm going to add a notify state task. And then I'm going to drag the left edge of the task notify state to the point where the character is going to begin. And then I'm going to scrub through the animation, find the point where the character stops. And then I'm going to drag this right edge of the task notify to that point. So if in your animation you had different parts that you wanted to ignore, you can add multiple notified states with a similar manner. So I'm going to delete this as we don't want to use this. The second thing that we need to do is for each notify state, we need to mark it up with a constraint. Since this is a locomotion, I'm going to mark it as constraint locomotion. And then finally, the third thing we need to do is enable root motion for the locomotion animation, because the system internally uses the root motion that this needs to be enabled. So I'm now going to save the animation sequence, close this, and go back to our motion data asset. And now I'm going to add a new array element, which is going to be this test injured run animation we just annotated. If I click save now, the feature vectors will be generated and will be saved inside the motion data asset. Now, if we hit play, we should see the character perform the injured run maneuver. And I can turn in the character performs the sharp turns which are recorded in this motion data asset. And now if I try to do a circular kind of motion, you'll see that the character might get stuck from time to time in a particular pose. And that's because we don't have that data inside our motion data asset. We can also confirm that the correct animation is being used by using the visual logging system. If you go to the window, developer tools, here you'll find the visual logger, which you can enable, which will bring up this window. If I hit record, and then if I start playing my animation, then the visual logger will record the various poses and the debug that motion flow performs. So I'm going to do a bit of motion here, and then I'm going to hit escape. Now if I click on the track that was recorded for the player controller, and if I scrub through, then you should be able to see the character perform the animation. And if you don't, if you see the character in a T-pose here, that means that in your viewport, the real-time option has not been enabled. Please do so now. So now if I scrub in the timeline for the visual logger, then we can recreate the motion that the character has performed, along with the various debug prints that the motion flow system did during the searches. So this is very useful for doing debug with the system. Now here at any point, you can see that the animation that the system is using is test injured run direction plant, which is the animation we just added. And if I scrub through the entire animation, you can see that that animation over here remains the same because that is the one animation we have added to the system for locomotion. Another usage of the debug system is the motion flow visual log debug, which I will talk a bit more about in a future video. But to quickly describe its usage, first let's see where we can find it. Again, it's placed under Windows Developer Tool, Motion Flow Visual Debug Log. So here what you can do is you can capture a particular feature vector, which then populates this feature vector element array over here. That is the feature vector that the system uses to perform the motion matching. And then you can compare the cost of this feature vector with any animation in your system. For example, this animation should again still be inside the animation request that generated this feature vector. So in this particular case, it will be one of the locomotion animations that we were using since we were doing locomotion. Since the only locomotion we have is test engine run, so that's the one I'm going to use. And then you can drag and find an animation time within the system, and it should produce a debug output over here, which you can compare with the best debug that the current pose produced. For example, for this particular pose and the feature vector that is being used right now, the system produced a total cost of 15.1, where the pose cost weight turned out to be 0, and then the future costs were 5 and 45 respectively. If you were not happy with the pick or with the weighting of the system or how your data was captured, then you can find a different time in your animation and compare the cost of that particular time with the time that the animation selected, which would be 8.36 seconds in this case. So we are comparing 8.36 seconds with 18.86 seconds, and we're comparing a cost of 51.09 with 68.47. So here you can get an understanding of why the cost was higher for this particular time. That's because in this case that pose contributed to a higher cost, and similarly the future trajectory looks like has contributed to a higher cost as well. So this is very useful in understanding lack of coverage in your animation data, and also understanding why a particular weight situation, weight configuration led to picking up a particular animation in the system. This is how ultimately you can replace your locomotion system, and you can start understanding the debug system as well. Hope this helps. Thank you.